In the previous lesson, Mary and Claire learned about a new unit of angle measure, the radian. A radian is the measure of an angle that cuts out an arc length equal to the radius. In this lesson, they will further investigate the radian as a unit of measure. They begin by estimating the measure of the two angles represented by these arcs in radians.
In the previous lesson, we looked at the following arcs. We decided that even though the first arc length was shorter, it represented a larger angle because the radius of the circle was smaller. So the question that we have for you now is approximately how many radians is each angle? So how are you all thinking about this?
Well, we were thinking we could do what we did yesterday with the pipe cleaners.
So Mary, you're working on finding the radius using pipe cleaners.
Yeah, the radians of the arc using the pipe cleaners. This one looks like it's about 2 radians. For A, it looks like it's 2 radians.
And how did you figure that out? Can you show me?
First, I used a pipe cleaner and then I marked where the how big the radian was, or the radius was, and then I cut it out. And then you like kind of bend it a little bit so it'll fit with the arc. And then mark where it ends, which was right here, and then one more, which is right here, and that's the end of that. And so that's like 2 radians for the arc length of A. And then for arc length D, I did this. I cut out the pipe cleaners for the radius for this, and now I'm going to bend it and measure it.
I see.
Mary has described how she determined the measure of the two angles. For each of the 2 circles that the arcs are portions of, she has estimated the circle's radius. She then cut a pipe cleaner so that it was the length of the radius. She could then use this length as a unit of measure. The number of radii that fit in the arc length will be the number of radians in the angle the arc represents. Now Claire will measure the angle in a different way. She will create a protractor using patty paper, similar to the ones they have used in previous lessons.
And Claire, what are you working on?
I'm working on making like something similar to the Gibbs circle that we had, but with radians instead.
I see.
So I'm kind of using the same method, like with the pipe cleaners, just to make it accurate.
I see.
But let's do this correctly. I need to stop closing this.
So I'm wondering if you could go on with your train of thinking of what you were going to do with your radian protractor. Like, what was your thinking before you decided it wasn't going to work?
I was going to try what we did with like the Gibbs, like measuring the center to like the outside. But since this is a bigger circle, it wouldn't work since we're measuring the arc length. Like if we were using the circle, because I guess we could technically. If we were using the circle to calculate the degrees, we could. But we can't really do the arc length since that's what we're focusing on. Because these are not going to be equal radians because they're larger and smaller circles.
Claire has raised an important concern. She is worried about using her radian protractor because the patty paper is bigger than the circle that the arc is a portion of. This is concerning because to measure an angle using radians, you need to measure the arc length. But bigger circles will have bigger arc lengths for the same angle. Before watching the rest of the video, pause and decide for yourself. When measuring in radians, does the size of the protractor matter? Why or why not?
But if you're measuring it like right here, then this kind of makes a smaller circle inside of that circle.
What?
Like, wait. Can I hold it down?
Yeah.
So this is the bigger outside circle, but if you measure it like this, then this kind of makes a smaller circle inside, and the lines are still the same, but the radius would be different because it ends at this circle. So you might be able to measure it using this. And look, it looks pretty similar to what mine was.
Yeah.
And then let's try this one. So see if you like go right in the middle.
Yeah.
And then to the outside, this kind of makes a smaller radius right here, and then this would be the smaller circle inside of the bigger circle.
You could.
So you'd be able to, like, look at, this is,
Yeah.
like, pretty much the same measurement, too.
Yeah. Okay. Never mind.
So can you explain the change of thinking you had?
Well, I mean, Mary kind of explained it really well to me. Like, since this is kind of transparent, you can see the other circle, and so it does make a circle inside of this. So, like, I'm trying to explain this in different words. Like, wherever the smaller circle hits on this is going to be a smaller fraction of the bigger radian, but it still works. Like, kind of like the problem yesterday that we did with the Michigan versus the Caribbean.
Yeah.
Like, the Caribbean was farther from that axis, so it was larger. So, like, this is the Caribbean, and this is Michigan. So it's still, like, on the same kind of spectrum. Does that make sense?
For this, it's like, because this radius is bigger, and that's why we thought we couldn't measure it, because the radius is bigger, so all of the radians would be bigger. But since you can see inside of it, it kind of cuts the radius to where the radius should be on this circle. And so that also makes this, it measures out this circle's, like, the radians. And so you can measure, this is 1 radian, and then this is 1, it's like 1.8, which is, like, about what I got. So it's pretty accurate using this circle, because it's like a smaller circle inside that you can use to measure it.
Yeah. So, like, even though the arc, the arc length of each radian is bigger, like on this circle,
Yeah.
the arc length is obviously going to be bigger than this one, for example. But, like, they have the same angle measure per radian. So no matter what, you can, I guess.
So every radian has the same angle measure?
Yeah, because it's always going to be split into about sixths.
So a radian is a radian is a radian.
Yeah.
In this episode, Mary and Claire used two methods to measure two angles in radians. In the first approach, Mary determined the angle measures by measuring the arc lengths the angles corresponded to in radii. She did this by cutting pipe cleaners so that they were approximately the length of the radii, and then measured the arcs using the pipe cleaners. In the second approach, Claire created a radian protractor using patty paper. She did this by dividing a patty paper into 6 sections, since there are about 6 radians in a full rotation. It is important to note that this is a little inaccurate because there are more than 6 radians in a full rotation. There are 2 pi, or about 6.28 radians in a full rotation. However, cutting a circle into 6 pieces offers a reasonable approximation of a radian. After making the protractor, Claire wondered if using it would work, since the patty paper was bigger than the circles the arcs were cut out of. However, the students decided it was okay. Although an angle will cut out a larger arc length on a larger circle than it will on a smaller circle, the radius will also be larger. This is why the size of a 1 radian angle will always be the same. A 1 radian angle will cut out a larger arc length on a larger circle, but the arc length will always measure 1 radius by definition. This means there are always 2 pi, or about 6.28 radians in a full rotation, because there are always 2 pi radii in the circumference of a circle. In the next episode, the students will draw an angle with a given measure.